Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Goprogman Taylor, and this is episode 5, Blazor with Ed Charbeneau. In this episode, I interviewed Ed about Blazor, what it is, a little background on WebAssembly, and how it all works. Some of you may already know Ed from the Eat Sleep Code podcast, which is also the official Progress Telerik podcast. He's also a senior developer advocate at Progress and a Microsoft MVP. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So first of all, I just want to thank you, Ed, for being on the podcast. It's a great pleasure to have you on here. One of the greats and the long-standing community drivers of Telerik, I guess. Is your podcast a Telerik product, or is it an Ed product?
Yeah, so I've been kind of in the community for about 8 years now, and I joined Telerik about 3 years ago and started up the podcast as part of my job as a developer advocate with Progress. Or Telerik. We go by Progress now, but the brand Telerik is still there. But the company that was Telerik got absorbed by Progress a few years back.
Okay, so is it better if I refer to the company you work for as Progress?
Yeah, it kind of confuses devs because we've been in the .NET space for such a long time as Telerik as a company. We got purchased 3 years ago by Progress, and the company is no longer Telerik, but we still maintain that brand because people know it so well from us being in the industry for so long. But yeah, the actual company itself is Progress now. We've been in the space since the early web forms days, and I actually was a customer years ago, so I kind of cut my teeth on Telerik tools as I learned my .NET skills. So it all kind of went together for me. So when I joined the company a few years ago, it really worked out. It was a nice fit for me.
Oh, that's cool. That's cool. So if you don't mind, Ed, for the incredibly small Venn diagram of people who maybe are listening to this podcast but either have not heard of you or your podcast, could you maybe introduce yourself and talk about your show a little bit?
Sure. My name is Ed Charbeneau. I'm a software developer turned developer advocate a few years ago. I've been doing software dev for about 15 plus years now. Mainly in the web development space, and done everything from full stack dev to UI design and all sorts of things. And now I spend my days working with the community as part of my developer advocacy with Progress. And I talk about front end web development with all of the .NET stack and a lot of the JavaScript tools as well. So if you've seen me out in conferences and stuff, you probably heard me talk about .NET and functional programming with .NET and ASP.NET MVC and responsive web design and Angular and all those fun web stack things that people love to use. And currently I have a podcast as part of my activities with Progress called Eat Sleep Code. It's the official Telerik brand podcast. We don't typically have our own content on there, which is nice. It's very much a community outreach type of a show where I get to talk to awesome developers from all around the community, and we talk about the things that they're interested in and working on rather than focusing on our own tools and things that we build. So it's a lot of fun to get to talk to those people and have them on the show. And I'm also a Microsoft MVP for the third year now, which phenomenal because I don't feel like I deserve it. I don't know. It's one of those things that just happened, and I'm very grateful to have it.
Well, congratulations on 3 years, I guess.
Thank you.
Definitely. I was at a meetup, a local meetup to me last night as we are recording this. With an MVP called Ian Cooper. And he'd said, because he runs a .NET user group in London, and he'd said that something along the lines of, I've been MVP for 15 years, which means I should be retiring and you lot should be taking my place.
Yeah, it's amazing how fast 15 years goes by.
Yeah.
It's like I felt like I picked up .NET yesterday and I'm still learning all the new things about it.
Yeah. Well, hopefully this won't make you feel too old, but hopefully it doesn't anyway. But I picked up .NET when I was at university. Our computer science course was in .NET, which, looking back, seems a lot easier to deal with than, say, if it was in C++. Because having to learn memory management alongside how to build your basic algorithms and things like that would have, I guess, been CS hard mode, I guess. But yeah, it's been good to me these past, my goodness, 15 years for me as well, I guess.
Yeah, I had the pleasure of talking about this all on the Developer on Fire podcast a couple weeks back. And man, that brought up some old school memories. Like I've been non-professionally, I've been doing software development like my whole life since I was able to touch keyboards and interact with computers. I've had some kind of activities that have involved programming. So it's kind of been a lifelong thing, but professionally it's been about 15 years.
Yeah. I feel like for a lot of people, there's two sort of origin stories, as it were, with development or software engineering. There's like I guess you or me, we've been doing it since we were, wee nippers, as we might say over here in the UK. So, small children. And then there's the people who come to it later in life who've maybe either had careers doing other things and decided, no, I want to get on this technology train, or maybe they've just decided to do it. But it makes for interesting discussions, when you get someone who has a purely academic background and someone who has a purely vocational background, you get that different exchange of ideas. It's really cool.
Yeah, it's definitely a fun space to be in. You meet a lot of interesting people that cross over from other professions and get into software because they had a problem they needed to solve, and they kind of like took up programming as a second hobby or something, and ended up making something really cool and transitioning their entire career over.
Certainly. But unfortunately, development backstories is not what we're here to discuss today, I guess. I thought what we could do is we could talk a little bit about Blazor, if that's okay.
Yeah, and those backstories actually will come in very handy because Blazor will kind of bring up some of these older frameworks and languages and stuff that we've worked with before, and we can do some comparisons there. So that should be interesting.
Okay, yeah. So I guess what we should start with is what is Blazor, I guess.
So Blazor is an experimental framework from the folks at Microsoft on the ASP.NET team. Mainly, it is Daniel Roth as the program manager and Steve Sanderson as the lead developer on that. And this came out of Steve Sanderson's it's his brainchild. So Blazor is a mixture of everybody's favorite .NET templating language, Razor, and it runs browser side. So Blazor is a browser plus Razor. So we get Blazor out of that. What's really interesting about Blazor is that it is using the WebAssembly feature of our modern browsers to run C# or .NET code on the local client in the browser.
But how does it do that then? If it's C#.NET in the browser, I mean, I know that we can run JavaScript, and I know that we can I think, is it Perl you can kind of run in the browser, but it gets a bit wobbly. So, like, how do we get from C#, I have a DLL if I'm in .NET Core world, or I have an XE if I'm in .NET Framework world, to running it in the browser?
Right. Excellent question. So what we have is web standards are moving forward, and they're now including a new target for putting our code in the browser, and that's WebAssembly. So in a traditional app, we'd have our HTML, our CSS, and our JavaScript. That all gets loaded into the browser, and then the browser takes the JavaScript, and it parses through that JavaScript, and eventually it actually turns that JavaScript into a form of bytecode. So it's doing this whether you're using WebAssembly or not, and that bytecode gets created, and then the actual execution of the code happens. So what they've done is taken that bytecode and opened up kind of an interface there. So instead of going through this process of sending the JavaScript to the browser and having the browser do this just-in-time type compilation and then turn that into bytecode, we can directly insert that bytecode into the application. And that's what WebAssembly is. So what's happened is the Mono framework, that's the .NET framework that runs all over the place on many platforms. It started off is running on .NET on Linux, and it also powers the Xamarin stack. So this is what we're using to do cross-compilation to iOS and Android. And now Mono is targeting WebAssembly. So Blazor is a framework that sits on top of the the Mono WebAssembly runtime. And what we do is actually send DLLs down to the browser. So you'll actually see these coming across the wire if you create a Blazor application. You open up your Chrome developer tools and you see literally netstandard.dll flying across the wire down to the browser, which is extremely odd because we're not used to seeing that, right? We're used to seeing these JavaScript files, but now DLLs are a static file type that we can use to send application code down to the browser.
Okay, so is WebAssembly specific to .NET? I guess would be the next question. Do I have to have a .NET app to be able to leverage WebAssembly?
So WebAssembly is actually an open standard that the browsers implement. So your evergreen browsers like Chrome, Edge, Firefox, even Opera, Opera may support it. I'm not 100% sure, but I meant to say Safari. Those things support WebAssembly natively. So you don't need any plugins. You don't need anything special. You just have to have a newer browser to be able to run WebAssembly.
Just so I'm understanding then, so we have a Mono runtime which can run on WebAssembly. So it's compiled down to WebAssembly, I guess. And then we load our apps on top of that.
Exactly right. So Mono is actually compiled to run on WebAssembly. Then our DLLs, those get loaded into Mono and interpreted, and Mono is taking the care of the heavy lifting. We technically could build and compile .NET down to WebAssembly directly. However, that compilation step would be a complex process and take quite a bit of time. So by using the Mono runtime instead, we're able to load those DLLs in and have a much smoother development experience. Because now we're just compiling down to an intermediate language, and then that's being picked up by Mono and utilized. So the compilation process is much, much smaller rather than trying to go all the way directly down to WebAssembly. Now, Daniel Roth has talked to me about this before, and I think he's mentioned it at Maybe Build, where their future roadmap, they hope to be able to have a final step in their compilation process that does exactly that and compiles the entire app down to that WebAssembly type of bytecode and can execute natively in the browser. But for the meantime, we're piggybacking off of Mono and using the Mono WebAssembly runtime.
But I wonder, is there much of a sort of operational slowdown converting, I guess, from .NET through Mono into WebAssembly down to JavaScript?
Yeah, so currently, yes. So you're not going to see a one-to-one performance, say, if you compared a JavaScript operation to something that's written in .NET and running through this stack of frameworks to interact with the browser. But that doesn't mean that the application is so slow that it's impossible to use. So the performance has actually been pretty good for me so far. And then, this project has only existed for about 6 months, maybe 7 now. So I mean, that's very early on. So this is, like I said at the beginning, it's an experiment right now. It's not an official product or anything like that. So we'd expect to see, beta type software behavior out of something this new. And we're not going to see the, top-notch performance out of it yet, but hopefully in the future, when they start implementing some performance tweaks and possibly even, like I said, compiling the app all the way down to bytecode at the very end, that final deployment package might be able to run at native speeds or even better.
Okay, that's really cool. So I guess we're getting closer and closer to the .NET Anywhere. Well, I mean, we have .NET Anywhere, I guess, at the moment, but I guess Blazor is one of the final pieces to getting .NET to run anywhere, I guess, because we've obviously got .NET Framework on Windows devices, Mono for what sounds like pretty much everything, .NET Core for Windows, Mac, and Linux, and I guess and the cloud. So, and obviously .NET Framework can run on the cloud as well. So I guess in the browser, is that the final runtime?
Well, there's always devices that are, IoT devices. So there's .NET on IoT. We can have it running on our Samsung televisions. I don't know if we could say that it runs everywhere, but I'm sure there's, we're covering most of the major areas where this can run. But the browser is a very big platform that we're kind of missing out on. We've had things in the past like web forms, which tried to do some abstraction on statefulness. That has kind of gone into the history books. People still write web forms apps, but I don't think there's a whole lot of brand new web form apps being written. And then we had Silverlight, which required a plugin, and I think we all know how that ended. It has ended. It has ended, folks. Like, it's done. So, we've had these ideas in the past of running C# in the web development process. And currently we're using things like ASP.NET MVC and .NET Core, where we do server-side rendering of some HTML and send that down the pipe. But at the end of the day, when we do interactions with the user, it's mostly through JavaScript.
What are the differences, I guess, between things like Silverlight, web forms, and Blazor, other than, I guess, Blazor is C# natively in the browser? I mean, is that the only difference?
So that's one of the main differences. So it's running client-side, and I will have a little caveat there and say there are other ways to run Blazor, and I'll try to talk about those near the end of the conversation because it can get really confusing really fast if we try to cover all the bases at once. But so you can run Blazor on the actual browser using C# natively in the browser. Now, other things that we've used before, like Silverlight required a plugin. So we had to go out and download a plugin, and then you would download your application and run it inside of that environment within Silverlight. So that kind of went outside of web standards. Right? You were no longer using HTML and CSS. You're using XAML and those technologies instead. And then with something like web forms, you're using web technologies, but you had this weird abstraction on state. So it didn't kind of embrace the web as a whole. It didn't. You didn't even know what type of HTTP requests were going across the pipe. It kind of was there to bridge the gap for WinForms developers to migrate their process to the web. So with Blazor, there's no plugins that are needed to download. It's fully web standard compliant. So Webassembly itself is a web standard that's being targeted through Mono. And then the C# assemblies are running inside of that runtime. So there's no special plugins. You're not going to have to go to a site and download something first before you can run a Blazor WebAssembly application. You just visit a site like normal, and the end user has, they don't know anything different. It looks just like a regular web application to them. Now, we have the other web standard technologies too. We're using HTML, we're using CSS. We can even choose to use JavaScript if it's needed, or if we just need to fall back on it for some reason. So what's really interesting about Blazor is there's an interop layer where we can actually talk back and forth to JavaScript modules. We can run JavaScript from within our C# code, and we can also run C# code from within our JavaScript. And we can get data and pass arguments back and forth through that layer. So that's some pretty interesting technology that we can leverage to not only fill gaps where WebAssembly may or may not have, say, APIs available, but we can also harness frameworks and technologies that already exist. I almost said legacy. I don't want to say legacy when that's kind of putting the cart before the horse. But something like, for example, Bootstrap, we could create a layer on top of this interop that lets us write C# code that interacts with Bootstrap, but it's actually running JavaScript under the hood. And at the end of the day, the developer that's writing the application, his experience or her experience may be just in C# without ever touching that JavaScript.
Okay. Would you class a Blazor application as being similar to a SPA or single page application, or should they be classified as something completely different, do you think?
So Blazor actually does run as a single page application style app. So it actually takes a lot of ideas that are found in frameworks like Angular and React, and implements those ideas in our C# language. And Blazor itself has similar concepts. Like, it has a component model, which is very easy to understand. If you take a look at Blazor code, it's very easy to get an idea of what's happening within that code. Basically, any CS/HTML file or Razor markup file gets converted into a component. So you write your markup in HTML, and then you can either write your C# code in an external file, or you can write there in the Razor file, the CS/HTML file. You can write an @ functions, and then you write your code right there in C# to interact with that markup. And you can do client-side interaction right there inside of that component, and then you can kind of package that up and reuse it throughout your application. It's very easy to understand and get running. It also includes a routing module, has dependency injection right out of the box, and like I said, it has that JavaScript interop as well. So you've got this nice package of tools inside of this framework that's really easy to get up and running and understand what's happening. And I kind of emphasize that because I've done Angular, I've done React programming as well, and the cycle of getting a new project up and running can kind of be messy. You have a lot of other technologies under the hood that you have to understand when you're doing SPA applications in JavaScript. You have things like Webpack and NPM, and you kind of have to tie these build pipelines together. And if you don't know how to configure your Webpack file just the right way, things don't work, and you don't get a whole lot of feedback from that type of a build system when something goes wrong. Because at the end of the day, it is a JavaScript system. So you end up with errors like undefined. And you're like, okay, now I got to go search for a missing comma or semicolon somewhere, instead of, what C# developers are used to. Generally, an intelligent message from the compiler that says, go check out this line of code because your compile failed somewhere.
Not just that, I guess. There's also a few of my personal projects. It's so easy to just go, oh, what's a node module to do this particular piece of functionality that I need? Because, there's a node module for everything, right? Or rather, should I say an NPM module for anything? And it's so easy just to pull down an NPM package and then you do an NPM audit and find out that it's 3 years out of date, and the security issues and stuff, and then you try and reach out to the author, and the author says, "Oh, I deprecated this package, but I forgot to tell everyone." Whereas I guess if we're using the C# tools and libraries that we already know, there's a more, I don't want to say a more stable ecosystem, but it certainly feels like, a NuGet package, at least to me, my experience being C#.NET almost exclusively, NuGet packages, if you find an issue or if there's a outdated package reference, it seems like they can be rectified a lot quicker.
Yeah, that's kind of been my experience as well. I feel like, it's a matter of preference. And I think there's quite a few JavaScript developers that enjoy that tool set and are very productive with it. And I don't think that it's a bad thing. I think it's great that they have something that works well for them. As a .NET developer who's done both sides of the equation, I often find myself struggling with errors and troubleshooting problems on the JavaScript side, just because there's not a lot of feedback, and it goes down to the basics of the language, right? It's not a compiled language. It just doesn't have those feedback mechanics built into it. So you get a lot of empty errors or undefines, or I even had one situation where I added a CSS file or a Sass file rather, to an Angular application, and that broke the build, and the application literally just didn't run. It's like, so here I am trying to style an application. I haven't made any code changes, but because of Webpack and how it operates, it spotted something in that Sass file that threw off the JavaScript in the application and crashed it. And the output on that was, it's one of those messages that you type into your web search and you come up with a million reasons why it could do that, and none of them have anything to do with what you're working on.
Yeah, I've had a few of those in the past couple of days where I'll do a Google Bing or whatever for a specific error message related to some esoteric thing that I'm doing. And, I'm working on a Windows machine, and all of the answers are, well, if you're on a Mac or you're on Linux, clear out this directory. And I'm like, that's lovely. But I'm on Windows. That directory doesn't exist, or this version of this software doesn't write to that directory. It feels sometimes as though some of those error messages can be a bit hit and miss. Have you tried this? Have you tried that? Well, last time I had this error, I jumped up and down 3 times and clicked the button and then spun around and it just worked.
Yeah, and I think it's also fair to say, like, people have probably struggled with MS Build from time to time. The .NET tool stack's not perfect. NuGet can be imperfect as well. It's just I've had less personal experience with those things. And also, if you're using C# on the client and on the server, then now you have just one tool chain to worry about. And it's a little bit easier to plan for those type of problems, because you don't have not only the problem of MS Build, but now you also have the problem of Webpack, and they handle errors completely differently. And it just kind of doubles the complexity of what you're working on. So now we have one tool chain that all uses the same language and build system and package management tools. And I'm sure, like, .NET developers have said these things many times. Now Node developers are probably going, yeah, now you understand how we've handled things for the last couple of years, because they've had that luxury for a while. So it comes full circle, I guess. I'm sure there's plenty of times where people are using TypeScript and C# developers are going, yay, now you know how we've been handling things for quite a few years now.
Yeah, exactly. But I mean, that's just how technology works, isn't it?
Mm-hmm.
Someone comes up with a wonderful innovation and it suits a lot of people it'll suit a small group of people or a large group of people, a particular area of the tech space. And then, knowledge of that will sort of start to bleed out. And like you say, because say you or I haven't had as much experience with these other build platforms, when we find errors, because we're not used to the error messages, they seem a lot more terse. So they take a little bit more, I guess, a lot more brain power to figure out, and a lot more time to figure out what the solution is. Whereas, like you say, if we're working with one tool chain with one or maybe two languages, I don't know, for whichever app you're building, maybe you're building the backend in F#, I don't know, then, it simplifies it a lot, because then I suppose the same thing could be said, like you said, the other way around. So like the Node folks are saying, we used to have to put up with, Apache or Nginx or I guess IIS running some server that we have no control over. And now we have a server which runs in JavaScript, which allows us that one framework, that one language, that one tool chain for both sides of the equation.
Yeah, like I said, I think it comes down to a matter of preference when these tools end up getting to where they're production quality. And I can't iterate enough. It's an experiment right now. So it's not quite there yet. But it is some really cool stuff to play with. And like one of the things that kind of concerned me at first is there's like this huge ecosystem built around web front end. So, we have a lot of frameworks that are available, and there's a lot of really helpful tooling that's out there. But what I quickly found out on the side of Blazor is that our .NET standard packages tend to work just fine in Blazor. So we also have this robust ecosystem of things that already exist that we can immediately consume with this. So this was a really cool thing that I experimented with. And I built a small demo app called Blazedown. So I took and created an online markdown editor, and just kind of keeping with the theme of browser plus Razor is Blazor. I called it Blazedown because Markdown plus Blazor is Blazedown. I thought it sounded kind of cool. And what I wanted to do is see if I could build a Markdown like document editor on the web. And I'm not a super genius. I don't know how to build a Markdown parser. I don't know the first thing about it, but I did go to NuGet and do a quick search and found one right away. I was like, okay, cool. So I have a Markdown parser. Now I just need to kind of wire the bits together. And I found that the Markdown parser worked perfectly well on the client running in the browser. So I was running a NuGet package that has existed for I don't know how long, and it's been used in desktop and other types of .NET applications. But now I was running it in the browser on the client and parsing Markdown text into HTML and displaying it in the window. And I thought that was just really cool, and that I was able to just pick up bits that already existed on a NuGet and reuse those.
Yeah, it is really cool when those things happen. And that's a huge thing, like you say, it's this NuGet package that was maybe built for some desktop app, or maybe built for some server-side rendering of, maybe I have a backing store that has Markdown in it and I want to send HTML to the browser. Well, now you don't have to. You can just send your Markdown to the browser and have the NuGet package reformat the Markdown for the user to consume. That's what I was trying to say. For the user to consume, so that they can see it and read it, and the browser can render it. And that's amazing,
Yeah.
I mean, I don't think we can. Oh, I guess with Webassembly, we could probably do that with C++ now as well. But that's not what this podcast is about. But it would take a little bit more effort, I guess. But that's amazing that you can have the same NuGet package being used on the client as well as the server, because you could probably reverse that NuGet package and have HTML being sent from the client to the server, converted to Markdown and stored in a database. Then when the user hits refresh, we read it from the database, send it over the wire, convert it from Markdown to HTML, and display it on the page.
Yeah, the app that I wrote, I just left it completely client side to just kind of demonstrate that it's a nice little editor, but you could run wild with all of it and make some really cool apps. one of the things that I found was really interesting in that process was first of all, how simple the code was, since most of it was abstracted into that Markdown library. All the work is really being done in there. A lot of the UI part of it was just kind of wiring up, a text box to a function that calls to that external library and, handles all the processing in there. And then I get an output and just render that to the page. So, I mean, the code is, you can open this project up and look at it, and it's, just a few lines of code here and there, and you can immediately understand how it works. Where I actually struggled and had a problem is the age-old browser problem that we experience, whether we're doing JavaScript or we're doing any other type of web development. And that's where I wanted the user to be able to click a button and download the Markdown and, be able to open that up on the desktop and say, continue editing it in a Markdown editor locally or something. Or, download it and share it. However, just get it out of the editor itself. So I started out with the idea of putting the download material into a data URI. So I kind of wrapped the content that was in the Markdown editor in this data URI, and then when you click the button, magically the browser understands this is a data URI. The payload is within the URI, and deliver that as a download. So you just click the button and boom, you get it. And then I opened Edge and you click the button and nothing happens. So after some research, I found out that Edge does not support data URIs. So you have to use a proprietary API that only exists on Edge. So the same problem that you'd have, 10 years ago with browsers handling things differently. I guess you could say incompatibility, for lack of a better term. But, that was raising its ugly head, and I ended up having to use that JavaScript interop because there's no native browser support for doing this download functionality. You have to actually tap into this Edge API to handle it, and it's in JavaScript. So there I was in JavaScript, writing that shim to kind of get Blazor to work in that way and provide that download button. But I was able to get it to where it works. So the app you can actually import from a URL. So you can import some Markdown from, say, a GitHub resource or some other web resource, and then you could edit that document, and then you can click a button and actually download a Markdown file and save it. So I thought that was a pretty cool full cycle application to experiment with.
Yeah, that sounds a lot cooler than the demo app that I created. We're going back a few months now, but when the Blazor, I believe it was the 0.1 preview was released, I got a little excited and wrote a little blog post about, this is really cool, you should check this out. And then a bunch of people that I work with decided, why don't we stay behind one evening and just have a mini sort of, not really a hackathon, but see what we can create with it. So I created a template, a .NET Core new template that we used that created, the base. It was essentially one of the demo apps, but with most of the stuff ripped out of it, just so you started with a blank slate so that we could get up and running. And I ended up creating an app that I called Blazor, much for the same reasons that I guess you did with your Markdown viewer and editor, in that it's keeping with the sort of Blazor Razor browser connection. And all that mine does is it displays a little text box, and you type in, I think it's a number between 1 and 750, and it tells you which Pokemon that is, and it gives you a bunch of images. You type in a value, and C# code on the browser does a web request back to the server to send the ID through. The server does all the hard work of contacting an API, but then it converts what it receives to a C# POCO, so a plain old C# object, and sends that down the wire to the app. And then the app uses the POCO to update the view, which is, obviously in the past we'd have had to convert that to, I guess, JSON or something similar on the server send it over the wire as JSON, then parse it back to JavaScript, and then display it.
Yeah, it's definitely taking a lot of ceremony out of writing a front-end application. I think it's got some serious potential. And in the last release, in Blazor 0.5.1, they added a new feature, which is I kind of alluded to earlier, but I didn't want to muddy the WebAssembly conversation, because Blazor, the framework, actually does not need WebAssembly. So it can run without it, but it can't run client-side without it. So Blazor can actually run on the server side as well. And if you're on the server, you don't need WebAssembly. You're just running C# code. So it runs natively on the server, but what they've done is they've separated the UI thread to where it can run across the web on a web request, and it uses a SignalR WebSocket. So the way the application is actually structured is Blazor runs on the server. You download the index file. That's the only thing you actually get from the server besides other static resources like CSS and JavaScript. But for all intents and purposes, you don't really have any HTML coming across other than this index file. Now, the index file bootstraps a WebSocket SignalR endpoint, and that connects up to the server that's running Blazor, and it processes all the UI across that WebSocket. So you don't actually have a client-side application in that scenario. It's kind of like a thin client or a dumb terminal. And it looks and feels just like a regular web application. The end user doesn't have any idea that it's not, built and structured like a normal, what we consider today a normal application, where you've got lots of HTML and JavaScript being downloaded. So this thing, it gets this WebSocket connection, and then if you interact with the browser, it kind of does a diff, and it says, all right, this, maybe this text has changed, and we need to do some kind of update on the UI, and it sends that package of data up the pipe, and it's doing this through a binary transfer even. So we're not sending JSON packets. We're actually just sending a binary diff package up to the server. And then the Blazor application picks that change up, processes the DOM changes that need to happen, and sends a diff back down. And then the browser updates the UI for us.
That's amazing.
It's very fast. So where we were concerned about speed earlier in the conversation, that concern is completely gone. It's only sending these tiny little binary packages back and forth when you interact with the browser. You're not sending down DLLs anymore. There's not a bunch of JavaScript flying over the pipe. It's just the the SignalR client gets spun up, and it's just a few K of JavaScript. And then it hydrates kind of the view into the browser. So it sends the HTML across the wire. The application client side picks it up and loads that into the browser, and then you're off and running. So there's very little data transfer in that. And then the actual updates are very tiny as well. It does kind of remind me a little tiny bit of how web forms worked, but there's not as much of an abstraction around state. So it's not kind of like this stateless thing that's happening. But you're also not doing a lot of HTTP traffic either. So it's kind of a new thing. It's very cool. So say, for instance, you have an NA framework database kind of abstraction. Maybe you have a repository pattern, something like that. You don't have to build like a web API endpoint on top of that. You can just access it directly from your Blazor application on the server, and it runs just like a normal .NET application. So you're not doing HTTP across the wire and all that to do data traffic. You can do all the processing on the server and only send down the the UI diffs that you need to make the UI look the way it needs to look. So that's a pretty interesting mashup of the Blazor framework and the brand new SignalR system that's been built. So it's quite a different take, and it's still the same Blazor framework. It's just running kind of in a different mode.
That is absolutely amazing. I remember when I was playing around with, like you said, in the earlier releases of Blazor, you had to download the .NET standard DLLs to the browser to make them, work, I guess, because you're running those DLLs, those NuGet packages in the browser. Mm-hmm. So obviously, if your NuGet package, if you unfortunately included things like Newtonsoft JSON, which is an amazing package, but it's, in the megabytes, your page is going to take a while to load.
Yeah. What's really weird is when you run Blazor server side, if you open the browser developer tools and you look at the traffic, you're interacting with the page and you can see data being, through the UI, it's being updated. So say you have a data grid or something and you see data populated in the data grid, and maybe you refresh that data or interact with that data, delete a record, something of that nature. You don't see traffic going across. You don't see a HTTP request like hitting an endpoint somewhere, like an AJAX request or anything. That's because it has this open pipeline, this WebSocket that it's transferring all the data through. So you don't see new requests. You just see that there's been a initial request. Then you can open a tool that the company I work for actually makes, and it's completely free to download and use. It's called Fiddler. So a lot of listeners, I would assume, have heard of Fiddler. It's pretty popular. But you can actually open up Fiddler and you can look at that initial request. And if you double click on it, there's a pane that opens up and shows the socket transfers. So you can actually watch the data going across the socket. You can't understand what the data is because it's binary, but you can see that requests are being made back and forth through that WebSocket, which is kind of neat.
Yeah, that is cool. I'm starting to imagine that maybe you could create because obviously SignalR allows you to do real-time bidirectional communications, like you say, over a WebSocket. So I'm thinking, at the moment, I'm thinking less a case of I create an entity and I delete it, more a case of maybe systems monitoring. So I could have maybe an admin dashboard that talks to a bunch of servers which are reporting on how my apps are doing. And if an app goes down, I don't have to refresh the page. I don't have to have JavaScript doing every second or every half a second or every minute or so doing a request to the server. The server can tell me when the app goes down.
Yep. And you don't have to use Blazor to necessarily take advantage of that. So you can actually do that type of thing with just SignalR itself. You could build a JavaScript only application that utilizes that technology. But with this Blazor style of doing it, the entire application code itself, you don't have a JavaScript SPA application that's running on the client anymore, which you could have a SignalR JavaScript SPA application. But in the case of Blazor, you don't even have that much. You're running the entire thing on the server, and the only JavaScript that's necessary is that one that kind of makes that initial connection. So the rest of the application gets fed through that SignalR pipe, and all the updates happen over binary transfers. It's just really cool stuff. Now, obviously, the downside to that is you have to have a consistent connection all the time. So this is not something that you can build and have working in offline mode. But as a developer that's worked in heavy manufacturing and other corporate type of industry settings, you often have machines that sit on a shop floor, and they could easily take advantage of a technology like this because that machine doesn't move, the computer that's at it doesn't move, and it's usually either hardwired or has a fairly consistent Wi-Fi connection. Whereas if you're building, say, like a mobile responsive app that somebody's going to be walking around in a cornfield with limited network access, it might not be the best option.
But then, like you say, it's different technology for different uses. Where we were talking about earlier on, we were talking about .NET, and we kind of picked on NPM. I feel like it was a bit unfair to pick on them, but it's the same thing with any kind of development. You pick the technology that fits the problem domain best, I guess. Not that it will. Because, let me rephrase that. There isn't one technology that solves all of the problems, but there are different technologies that solve problems in different ways, I guess. And it's picking the right one, like you say. If you have someone out in the field who doesn't have a constant internet connection, you don't want to give them something that relies on a constant internet connection. But like you say, if it's a system that's inside of an office or inside of a factory where things are happening and you can rely on that connection, then yeah, you can do that.
And I know in my career I've built some very simple applications, simple in the respect of the technology they use, a .NET app with not a whole lot of code behind it, but it solves a really complex problem very easily. And you don't always write like the next Facebook or Netflix app, right? You don't always need Angular and 30, 40,000 files that come along with a framework of that magnitude. Sometimes you just need a VB6 app or some little WinForms or Web Forms type app to get a whole lot of work done, because it's simple to create an app around a process. And maybe you have some machines within that factory that are already in place and they have a network connection. And just by adding these small apps, you can increase productivity in that setting very efficiently. And I think people forget that often. And they see a framework and they're like, oh, I'm going to build the next big, gigantic, multi-tenant Netflix style or Facebook style application with Angular or React. And a couple weeks go by and there's so much code and stuff in that stack that it's almost impossible to figure out what's going on if you didn't build it and document it all yourself. But there's a lot of opportunity for big wins with small apps for very custom type of things, and I think we lose sight of that. And I think Blazor is something that could fill that gap very easily.
So because Blazor is a Microsoft experiment, is it open source, or have they closed it off whilst they're sort of doing their experimental phase?
No, it's actually open source. You can find it on GitHub. I can't remember the URL directly. I think it's github/ASP.NET/Blazor. And they do accept pull requests, and you can get in there and file issues, which I've done quite a few. Since it's very, very early in development, there's things that just don't exist because it just hasn't had time to mature enough. So it helps the team that's working on it decide on the roadmap if you get in there and raise issues or go in and kind of comment on issues and let them know what's important and what you'd like them to consider working on next and put in their roadmaps. That stuff's been helpful as far as feedback that they've given me. That's very helpful to them. Another thing that they've expressed is helpful is just kind of providing feedback on, is this something I could use? Like, is this something I'd like to see more than an experiment done on? I think that would be helpful feedback to the team as well. And they actually have a survey if you download and run your Blazor app template. There's a link you can click on right in the example that'll take you to a survey where you can fill out that type of information.
So I've been using a phrase where I work, unofficially naming an umbrella, the core technology, so .NET Core, ASP.NET Core, EF Core, SignalR, that kind of thing. And I really like that these things are in the open and that Microsoft are literally developing them in the open. You can see the pull requests and the commits come through. But much more than that, I like that they are engaging with the community and asking for, like you say, asking for feedback. But not just that, but asking for people to vote on things So even if you're a developer like me, I suppose, I don't think I'll ever be able to have a pull request into Blazor because it's way over my head, or at least that's how I feel at the moment. But I know that I can go on there and I know that my vote matters. This feature, being able to stream files would be good, or, being able to, whatever, being able to do this feature or that feature. We'd like these, we'd like those, because I guess, like you say, it helps the engineers who are working on it to prioritize which features to add, because I guess at the end of the day, they're building the technology for us to use. They're not building it for them to use, I guess.
Yeah, and I think it helps them get visibility into what people actually need rather than try to guess what people are intending to build with it. So it gives them more of an accurate representation of what needs to be done with it. And it's great that they've got an open dialogue going and they comment back on issues, and I've seen things get worked on and implemented. One of the examples is there was no way to render raw HTML at the beginning. If you didn't do things through their component model, then it just didn't do anything else. So there was no way to manipulate the DOM in any other way. So that was kind of a hurdle for something like a Markdown editor that I was building, because you couldn't render that Markdown out without jumping through a lot of hoops. Another issue that I brought up that's being addressed is it was kind of a future forward kind of idea. Browsers have now implemented a standard around JavaScript modules. So if you've done any modern JavaScript development, you've probably used Webpack or, gosh, I'm trying to remember the other names of those tools that kind of do the Babel.js and other bundling and compilation style tools where they support different module patterns in JavaScript. Now that's actually a native browser thing. So you can use import and export statements in your JavaScript and create real JavaScript modules, and you can actually utilize those in the browser natively. So it's asking for some support on that because of the JavaScript interop. I think it'd be an easy way to package up your JavaScript libraries that need to go with those interops. So instead of having many JavaScript files in some kind of build system to create something that the browser understands, you can now just do that natively through JavaScript modules using the valid syntax. So having support for that, I think, would clean up the interop situation a lot better. And they've actually taken notice of that issue and put that in their work queue. So it's really cool stuff.
Yeah, it really is. I'm really interested to see where we go with Blazor in the next, say, year or so. Like you said, at the time of recording, we've had a fairly recent 0.5.1 release, and that's only about 6 months since the initial release. So it's going pretty rapidly. It's an experiment which is very quickly, maybe very rapidly, reaching a 1.0 release.
And there's not a lot of documentation out on it right now, which is, again, understood because of the newness of it. So if you're looking for information, you can find me on online at edcharbeneau.com. I've got some blog posts that are in the works and should be live, and sometime in September these blog posts will be coming out. And I'm not quite sure where they're going to be published yet, so if you find me at edcharbeneau.com or Ed Charbeneau on Twitter, I'll let you guys know when those blog posts become available. And I'm doing some projects around how all of the templates are structured and what you're going to find inside of those templates, as well as how to work with the JavaScript interop. So one of those files or one of those blog posts will be published on LogRocket, and then probably blogs.telerik.com and maybe even MSDN. We'll see. But I've got some content coming in that way. And then I've also got a Channel 9 video that I recorded at the Channel 9 studios that should be airing on the Visual Studio Toolbox program within, say, a few weeks. So that stuff will be out, and I'll tweet about that stuff when it comes around. So just give me a follow on Twitter or check out my website, and I'll update everyone on where to find that stuff.
Sure. See, that was going to be my next question. Where can people reach out to connect with you and to ask questions and find out more about yourself and maybe more about your experiments with Blazor and obviously listen to your podcast?
Yeah, so the podcast is, the easiest way to find it is to look for it on SoundCloud or iTunes and look for the Eat, Sleep, Code podcast on one of those two outlets, and like or subscribe there. And I've been doing a show probably every 2 weeks. I'd like to get those back up to every single week. Depends on my travel schedule, though, so you might see the episodes come and go a little bit, but we try to get new content up there. I've got some guests lined up for the next few weeks, and we've had some really great people on there in the past as well. So check out that back catalog. I actually had Daniel Roth on there talking about ASP.NET Core 2.1 not that long ago. So it was a good show there.
Definitely check out Ed wherever you can find him and listen to his podcast for sure. Did you mention where people can connect with you?
Twitter is probably the best way to connect with me directly. And I go by my name on Twitter. I'll give you that for the show notes as well, in case people can't spell the name. My last name is not the simplest, but I go by Ed Charbeneau on Twitter. If you give me a shout on there, I'd be happy to answer questions and get in touch. So that's the best way.
Fantastic. Thank you ever so much for being on the podcast, Ed. It's been a real pleasure and a real treat to learn all of these different things. I'm trying to keep my fingers in as many pies, as we would say over here, to do with all of the, like I say, that umbrella term that I use, the core technologies. But sometimes with everything being released, it feels like a news release or a press release every day. So trying to catch up with all of those is a bit difficult. But, hearing it from people like yourself helps to make it a little easier to take in.
Well, thank you for having me on and setting aside some time for me to talk about Blazor. It's been a lot of fun.
Thank you very much. That was my interview with Ed Charbeneau of Progress Telerik. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered, and a collection of text snippets from the interview. The show notes, as always, can be found at dotnetcore.show. That's dotnetcore.show. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice, and come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.